So we did some graphing of equations. Now we're going to do the algebraic solution to a system of equations. Now a system means we have two equations, and we're going to find a numerical answer for both x and y. So we're going to end up solving for two numbers, one for x, one for y. I'm going to show you two ways to do this. Well, one of the ways you already learned was to find where the two lines intersect on a graph, so the point of intersection, but today we're going to do it algebraically. The first way I'm going to show you is called substitution. The second way is called elimination, and then we'll practice some word problems, and then that'll be it. So, substitution. To do substitution, it means replace one thing with something else. So if you notice, our equation is written where y is already by itself. And to do a substitution, you have to get one of the variables by themselves. It doesn't matter if it's x or if it's y, but one of the variables has to be by itself. So if y is equal to x plus 12, that means in the other equation, I can replace the letter y with the full expression x plus 12. That creates one equation that has all the same variables. Because the issue that we have with what we start with is two equations and two unknowns. I need one equation that has all the same variable in it. So this substitution will do that for us. So the 2x stays a 2x. And this is 4 times y, so I keep the 4. And in parentheses, in place of the y, is where I'm going to put in the x plus 12. Everything else around it stays the same. Now that I have one equation with all the same letter, I can just go ahead and solve. I'm going to solve, excuse me, by first distributing the 4 into the parentheses. 4 times x, and using my calculator, 4 times 12. Everything else stays the way it was. So now I'm going to combine like terms with the 2x and the 4x. I'm just going to put those together as a 6x. And solve like we've solved before. Subtract 48 from both sides. Six x equals negative 24. And then divide by 6 to get x alone. So I get x is negative 4. Now that I know that x is negative 4, I can go back up to where I started, and since y is equal to x plus 12, and I now know that x is negative 4, I do negative 4 plus 12 to get y is equal to 8. There's my y value. Here's my x value. I've solved for x and for y. So let's do that again, another substitution. And remember, guys, if I'm going too fast, pause it so you can write things down, or you can rewind it and rewatch the video as much as you want. Okay, so to do the substitution, we need either x by itself or y by itself. So to get y alone for this first equation, I can just simply subtract 3x from both sides. Kind of like when we were graphing, we would get x alone, and I could recognize what the slope and y-intercept is. I just need the y by itself. If you want to do this with both equations, we can. And since they're both equal to y, I can just set them equal to each other. It is just substitution. I can replace negative 3x plus 4 in for y into the other equation. Now I have x's on both sides of the equal sign. We need to get them grouped together. So I'm going to add 3x to both sides. And then I'm going to add the 3 over to get x by itself. And then 4 plus 3 gives me 7 equals 7x. Divide by 7. And then any value divided by itself is just 1. So I get x equals 1. Now that I know x, I can take that and either one of the original equations, it doesn't matter which one you pick. You can even use one of the rearranged versions. So I'm going to take the x and plug it in and solve for y. 3 times 1 is 3. Subtract the 3. So I get x equals 1 and y equals 1. So here's what I want you to do. Pause it, try this example for yourself, on your own, and then turn it back on and let's see how you did. If you need me to walk you through it again, then don't pause it, and I'll do it, but I'm going to do it quick, okay? So to get y alone, I would subtract the 5 over. Then I'm going to substitute that in for y into the other equation. I'm going to combine the 5x and the 2x. And then I'm going to add 5 to both sides. And then I'm going to divide by 7. Now that I know that x is 2, I can plug that in. I can use either one of the equations. Doesn't matter which one I use. You just look at them and decide which one do you think is easier for you, and then that's the one you can use. So I got x is 2 and y is 5. All right, so that's substitution. If you can get one of the variables by itself, do that and then substitute it into the other equation. Now, I did mention that it doesn't always have to be y as the one that you get alone. So here's an example where x is already by itself. So I can substitute 3y minus 27 in for where the x was. So instead of x, I'm going to put in the 3y minus 27. I'm going to distribute. 3 times 3y is 9y. 3 times negative 27 is negative 81. So I have y's on both sides of the equal sign. I'm going to subtract y from both sides. That's going to make it negative y here, so it cancels, and 9 minus y on the other side, that's going to make it 8y. So now I'm going to add the 81 over so I can get y by itself. And I'll get 8y equals 88. Divide by 8 to get y is equal to 11. So this time I found y first. Now I'm going to take the y value of 11, plug it in so I can find x. I get x is 4. So that's substitution. Now the elimination method works best when I have numbers in front of all the variables. So I cannot easily get one of the letters all by itself, so I'll use elimination, and I'll show you. The idea behind elimination is to stack the two equations, one over the other, and then add them together so one of the variables cancels out. But in order for that to happen, we have to do a little bit of manipulation with the numbers to change how it looks. So here's what I mean by all that mumbo jumbo. If I take this second equation and write it underneath the first one, 4y minus 3x equals negative 10. If I were to add these two equations together right now, nothing would cancel out and nothing would disappear. So what I have to do is I make a decision as the person solving this problem whether I want the y values to cancel out or whether I want the x values to cancel out. It doesn't matter, you get to choose. If I want the y values to cancel out, almost like how you would get a common denominator in a fraction, I would multiply the top equation times 4, the bottom equation times negative 5, or times negative 5, and that way they would both end up a 20 y value. Or if I choose to cancel out the x's, I would multiply the top equation by 3, negative 3. So that's what I'm going to do. I choose to multiply the top equation times negative 3. And doing that will change that top equation using the distributive property to negative 15y, then plus 3x, and negative 3 times 15 is negative 45. So that changes how the numbers look and just made everything 3 times bigger. The equation underneath it, I do not need to change because the work I did set up my problem So when I add the two equations together, I have a plus 3x and a minus 3x. They will cancel out. They are eliminated. That's why it's called elimination. The rest of the numbers, that just whatever happens, happens, and I solve from there. So if I do negative 15 plus 4, I get negative 11y. And negative 45 minus 10 more is negative 55. Now I just simply divide by negative 11 and I get y is 5. So after I do the manipulation with the equations, something cancels and the last couple steps are very easy. Once I have y is equal to 5, I know that y is 5, so I can plug it in and find my x. Subtract the 25 from both sides and divide by negative 1. So we get x is 10, y is 5. So let's do another one of those elimination methods. One of the things that we have to have is all of our variables aligned in the same order. So this has x first, y second, and then equals the number. Make sure the second equation is in the same order. The x is first, that's good. The y is second, that's good. And equals the number, that's good. Now we make the decision as the person solving the problem. Do I cancel out the x's or cancel out the y's? If I cancel the x's, I multiply the top equation by 3 and the bottom equation by 2. Since one of them is already negative and the other one is already positive, I don't need to worry about changing the signs. If I'm looking to cancel out the y values, notice they are both positive. So I would have to multiply one of the equations by negative and the other one by a positive so that they end up opposite signs. They need to be opposite signs so that they cancel out when I add the equations together. So let's cancel out the y values this time. In order for this to happen, I will multiply the top equation times the 4, and I will multiply the bottom equation times the 3. So the 4 that was in front of the y of the second equation gets used to multiply the first one. And the 3 that was in front of the y on the first one gets used to multiply on the second one. They are both positive right now. I'm going to use a negative on the bottom equation so that they end up the opposite signs. Now we distribute, rewrite our equations, and then the y's will cancel nicely. So 4 times negative 2x is negative 8x. 4 times 3y is 12y. And then 4 times negative 12 is negative 48. Now I'm going to take the negative 3 and distribute it. So negative 3 times 3x is negative 9x. Negative 3 times 4y is negative 12y. And that's what I wanted, a positive 12y and a negative 12y. That's why I picked those numbers the way I did, so they would cancel. Then I jump to my calculator and do negative 3 times 52, and I get negative 156. So now I combine like terms. And when I do that and add the equations together, the y's cancel out just like I wanted. Negative 8x minus 9 more is negative 17x. And negative 48 minus 156 more is negative 204. Divide both sides by negative 17. Go to your calculator and we get x is negative 12. Now that we know x is negative 12, pick an equation. Doesn't matter which one. I think I'll pick the first one. The numbers are a little smaller. Put in negative 12 for the x, and we are going to solve for the y. Multiply the negative 2 and the negative 12. Subtract the 24 from both sides. Since I am subtracting the 24 from a negative 12, negative 12 minus 24 more will be negative 36. And negative 36 divided by 3 is back to negative 12. So our answers are x is negative 12 and y is also negative 12. All right, so take this next equation, pause the video, and try this on your own. Solve for A and solve for B. So pause it, try it, and then come back on. So I'm going to rearrange some things here. I need to bring the 7b over and move the 14 to the other side. And I need to bring the 3a over and move the 41 to the other side. That way everything's in the same order. So I subtracted the 14 from one side and the 7b. And then in the other equation, I added the 41 and added the 3a. That just moves stuff around. So now I have my equations 2a minus 7b equals negative 4. And underneath it, I noticed that the b's already have opposite signs. So I can just multiply the top equation by 5, the bottom equation by 7. Or if I want to keep my numbers smaller, which is what I'm going to choose to do, I'm going to multiply the top equation times 3, and I'm going to cancel out the a's. The bottom equation times negative 2 to cancel out the a's. So my new equations become 6a minus 21b equals negative 12, and negative 6a minus 10b equals negative 82. When I add these two equations together, just like I wanted, the a's cancel out. And then negative 21 minus 10 more is negative 31. And then if I do 94 divided by 31, okay, so I just noticed, because this didn't divide out evenly, that I wrote a 4 instead of 14 over here. So you're going to see my work magically change as I pause it, change it, and start back up again. Hang on a second. Be right back. All right, so this is a simple little change. That should have been a 14 instead of a 4. 3 times 14 makes this a negative 42. And then when I add these together, negative 42 and negative 82 combine to be a negative 124. That's what I was supposed to have. Negative 124 here. Now divide by negative 31, and I get b is 4. Now that I know that b is 4, choose one of the original equations to use that b value of 4. And solve for a. Subtract 14 from both sides, divide by 2, and there we go. Worked out nice. Now what we're going to do is practice some word problems, and you'll have a couple word problems on your test, so make sure you do some of these with me. All right? Okay, if you need a break, you can pause it, but I'm going to keep on rocking it. All right. Mr. Ties and Shirts bought 7 shirts of equal value and 4 ties of equal value for a total cost of $150 at Mr. Stewart's Fashion Emporium outlet store. At the same time, Mr. Shirts and Ties bought 3 of the same shirts and 5 of the same ties for a total of $84. What is the cost of 1 shirt and 1 tie? So, sounds confusing because I made up some funky names, but I did that just to try to get a smile out of you. Mr. Ties and Shirts. We're talking about shirts and ties. So if I let X be the cost of a shirt and Y be the cost of a tie, now I can make my equation. To start with, 7 shirts, 4 ties, $150. 7 shirts plus 4 ties is $150. Second equation, 3 shirts, 5 ties is $84. 3 shirts and 5 ties is $84. Now we're going to use the elimination method, and we're going to solve for x and solve for y. So you get to choose whether we solve for x or cancel out the x or cancel out the y. I think I'm going to cancel out the y values first. So I will multiply the first equation by the 5 and the second equation by the 4. Since they are both plus, I'm going to make the 4 a negative. Now I'm going to distribute and rewrite my equations. So 5 times 7 is 35. 5 times 4 is 20. And 5 times 150 is 750. For the second equation, I'm going to distribute in the negative 4. So negative 4 times 3 is negative 12. Negative 4 times 5 is negative 20. And then 84 times negative 4 is negative 336. Once I have those set, I can go ahead and combine terms. And just like what I was hoping for, the y values cancel out. I do 35 minus 12 to get 23x, and 750 minus 336 is 414. Divide both sides by 23 to get my x value of 18. So that means one shirt cost $18. Now I have to take my 18 and use either one of the given equations to find y. So 3 times 18 is 54. I have to subtract 54 from both sides and divide by 5. So that means each shirt, one shirt costs $18, and one tie costs $6. Bada bing. Okay, next page, next example. This one, I was talking about attendance at tickets for a rally. So the total attendance at a rally was 750 people. Tickets bought before the rally sold for $2 each, and tickets at the door sold for $2.75 each. How many tickets were bought at the door? If $1,706.25 was the total amount of money generated from ticket sales. So we have two types of tickets, and that's what we're going to use for our let statement. We have to define the variables. That means tell me what the letters you are using mean in the problem. So if X is the tickets sold beforehand, and Y will be the tickets sold at the door, and according to this, they sold 750 tickets. So the total number of tickets before and at the door ended up 750 tickets. So one equation is the number of items. The second equation will be the cost, money. So the tickets that were sold ahead of time were $2 each for a ticket sold ahead of time. And then add to that $2.75 each for the ticket sold at the door. And they generated a total of $1,706.25 in money. There's your two equations. Now we could use substitution here, because in this first equation, I can just easily subtract x across the equal sign and get y alone. And then I can substitute 750 minus x in for the y value, and then I can solve for x. So why don't you pause it, get your value for x and y, and then turn it back on, and we'll see if you did it right. And bam, welcome back. So I substituted the 750 minus x in place of the y, distributed the 2.75, combined like terms and solved for x, and I got 475 tickets for x. That means 475 tickets were sold before the rally. Taking that number and subtracting it from the total 750 means 275 tickets were sold at the door. So our before tickets were 475, and at the door tickets is 275. And there we go. Okay, number 3, consecutive integers. Consecutive integers are numbers that are counted right in a row, like 1, 2, 3. Those are consecutive. Integers means no decimals, no fractions. Consecutive means in order. So 3 consecutive odd integers. Now the fact that they are consecutive odd integers means something like 3, 5, 7. They have to be odd numbers in a row. So if x is my first consecutive odd integer, the next odd number is 2 more than that. Like if you count odd numbers, 3, 5, 7, 9, 11, you keep counting up by 2s. So x plus 2 would be the second number, and x plus 4 would be the third. So those are expressions to represent the 3 consecutive odd integers. Now we have to interpret the words to make an equation. All right. 4 times the smallest, 4 times the smallest, that's the first one, and 3 times the largest, 3 times the largest, have a sum, that means they added, of 33. So there's our consecutive integer problem. It's only one value of x that we're worried to find, one equation, so this is easy. Pause it, solve it, and restart. So we get x is 3 after we solve it, which means my first odd number is 3, the next odd number is 5, and the third odd number is 7. 3, 5, 7. 3 odd numbers in a row. All right, so number 4 is another question about tickets, similar to what we did at the top of this page with question number 2. So I would like you to read it and try to do it all on your own, and then come back and we'll see how you did. So I'm going to go ahead and use X for tickets sold in advance and Y for tickets sold at the door. And they sold a total of 225 tickets. The advance tickets were $4 each. The at the door tickets were $5 each, and they raised a total of $950. You could use elimination or substitution. I am going to choose substitution. And I'm going to substitute that 225 minus x in for the y. And I'm going to distribute the 5 and then subtract the 1125 from both sides. And 4x minus 5x is negative 1x left over when I combine like terms. Divide by negative 1, and there were 175 tickets sold in advance. Subtract that from the 225 total that we started with, because in order to find y, I take the total 225 minus the x of 175 and get 50 tickets sold at the door. 50 tickets sold at the door, 175 tickets sold in advance. Next question talks about water slides and Ferris wheels. So I want you to pause it, read it, and try it, and then come back. So I use W for water slides and F for Ferris wheel. So three water slides and 3 Ferris wheels was a total of $17.70. And then 2 water slides and 3 Ferris wheels was $15.55. Notice that the F's are both a 3F. So what I'm going to do here is I'm just going to subtract the 2 equations. Now that basically means I'm going to distribute a negative 1. So I'm going to do 3W minus 2W, which is 1W. 3F minus 3F cancels out. And then I do $17.70 minus $15.55, which is $2.15. So right there, I get one water slide ticket costs $2.15. Now that I know that, I can use either equation that I created to find the cost of a ticket for a Ferris wheel. So 2 water slides and 3 Ferris wheels was $15.55. If I do $2.15 times 2, that's $4.30 or 4.3. I'm going to subtract that from the 15.55. And I get 3 Ferris wheel tickets, totals $11.25, which means 1 Ferris wheel ticket when I divide by 3 is $3.75. So the water slide was $2.15 and the Ferris wheel was $3.75. And that brings us to our last question of the day. The admission for a small fair is $1.50 for children and $4 for adults. On a certain day, 2,200 people entered the fair, and the fair collected $5,050. How many children, how many adults attended? So I would like you to pause it, try this on your own, and then come back and we'll see how you did. So I used A for adults, C for children. Total number of adults and children combined was 2,200, and it was $1 or $4 for every adult, $1.50 or 1.5 for every child, and they raised a total of $5,050. So you can use substitution or you can use elimination, but pause it, try it, and we'll see how you did. So I used A by subtracting C on both sides. I used A to substitute in for A, and then I solved for C. So when I did all the math, distributed the 4, combined like terms, subtracted 8,800 from both sides, divided by negative 2.5, I got the number of children tickets, or number of children on this particular day was 1,500. Now they told us at the beginning that there was a total of 2,200 people. So if I take the 2,200, subtract out the 1,500 students, then I get the number of adults for the day, which is 700. So, number of children, 1,500, number of adults, 700. All right, guys, have a wonderful day. Thank you for your time, and enjoy the afternoon, or night, or morning. Who knows when you're doing this.